name is Jacqueline Viola, and I'm the recipient of the Endowment Fund Scholarship. I am a PhD student at the School of Plant and Environmental Sciences at Virginia Tech. My graduate project involves the interaction and relationships between soils, grapes, and wine. Virginia has a thriving wine industry across diverse geology and soils, but one of the constant challenges of growing wine grapes in the eastern United States is our humid climate. For instance, 2018 was not a great year for growing wine grapes in the Mid-Atlantic. There was too much rain during bud break and much of the growing season. During harvest, the threat of Hurricane Florence forced many growers to choose between harvesting early or risking increased disease pressure, saturated vineyard conditions, and splitting fruit. My research looks at the soil component of this issue. Basically, I dig holes in vineyards, sampling the soil for nutrients and looking at soil features including texture, structure, available water capacity, and topsoil thickness. Then, I relate that to vine growth and potential wine quality, including wine color, stability, and flavor. I am especially interested in the effects of soil hydrology and potassium release potential. I currently have 5 sites around Virginia and Maryland, all with different and interesting soils. I'm very grateful to these vineyard owners for allowing me to dig in their vineyards. I hope my research will provide management options that will inform these decisions and enhance wine quality in challenging years. As the saying goes, the wine is made in the vineyard. I'm proud to be part of this industry, and I really appreciate the years of support from the American Wine Society. A huge thank you to AWSEF. Thanks.
My name is Suzanne Fleischman, and I'm a PhD student at Penn State, where I study 2 different management practices and how they impact root function. And this is a really great time to show you all how 2 different management practices, cover cropping and root stocks, can influence growth. So in humid climate vineyards like we have in the eastern US, our soils are really fertile and have a lot of moisture, which can cause excessive vegetative growth in grapevines. And as you can see, when you have a lot of green growth, there's shading of the clusters. That creates a really great microclimate for diseases, especially fungal diseases. These very shaded clusters are growing with our standard floor treatment in vineyards, which is an herbicide treatment. And what we do is, while we'll have grass on the inner rows where we drive throughout the vineyard, we'll actually spray herbicide in a strip directly beneath the vines. The reason that people traditionally do this is because they don't want weeds or other vegetation to compete with the grapevines for water and nutrients. So in order to better understand how to pair different ground covers and cover crops with the grapevines, we need to do research on the roots, the site of where they're competing, which is the focus of most of my research. And so to do that, we use these root boxes, as you can see here, between the cover crop and the herbicide treatments. And from these root boxes, we can collect a lot of different information about the roots. Most importantly, though, we can see exactly where the cover crop roots and the grapevine roots are growing close together. That is not necessarily possible if we were to use other methods of researching roots, such as taking a soil core or digging a trench. So from tracing the roots and seeing where they are in the box, we can collect a lot of information about them. This includes how old the roots are, how close they are to the different cover crop roots, and the type of root they are. All these different factors might shape what bacteria and fungi live on the roots.
Hi, I'm Alex Fredrickson, a PhD student from the University of Missouri in the Department of Food Science under the advisement of Misha Kwitzinski. My passion for the wine industry stems from working long days of harvest across the US, New Zealand, and Australia, where I made lifelong friends and watched tradition and history blend with modern science to make amazing wines. My experience in winemaking led me to a number of scientific questions, and to my surprise, after all these years, there's still a number of unknowns. I've been fortunate enough to work with one of those questions during my PhD research, which is why do some red wines have 10 times more tannin, while the tannin in the fruit of those same cultivars or wines are actually quite similar. Tannin is crucial in red wine because it leads to improved mouthfeel and complexity of the wine, Tannin is also an antioxidant which has health benefits for human consumption, but also helps reduce the risk of oxidation in wine. Most importantly, tannins also associate with anthocyanins called copigmentation. Without copigmentations, anthocyanins are not very stable on their own, and after about a year in wine conditions, that red-purple color you like to see in wine usually turns a brown color. But with copigmentation, that deep red color can last for 10 plus years. With reduced copigmentation, the color in low tannin wines is not as stable when compared to wines with excess tannin. The low tannin wines are often sold at lower price points and labeled as drink now wines, making it difficult to compete with the premium wine market. I've identified over 1,000 different proteins in juice and wine, with a number of those proteins having an effect on tannin retention. I'm further characterizing individual proteins and polysaccharides to help understand if there's a specific reason why these compounds react more with tannins. With this information, it is hopeful that I can shed some light on tannin retention across different cultivars. I would like to thank the American Wine Society, and in particular, the South Carolina Toller chapter in memory of Hal Khan. Their support has allowed me to travel to conferences and present my work, as well as collaborate with other wine chemists across the U.S. Thank you.
The Pennsylvania wine and grape industry is widespread across the state, and already in my program I've had the fortunate chance to work with many growers in the industry. Hi, my name is Drew Harner, and I'm a PhD student at Penn State University, where I study grapevine physiology and wine grape chemistry. Specifically, I've been able to explore this interest through a variety of projects, including one that looked at various levels of leaf removal and how it affected Gruner Veltliner wine grape chemistry and physiology. Gruner Veltliner is an Austrian white wine grape variety that is important to the Pennsylvania state wine industry. In this project, we assessed various levels of leaf removal in order to see how these levels affected both cluster and grape qualities, including the presence of many important aroma compounds. Additionally, we've also been interested in investigating the potential regionality of Gruner Veltliner grapes and wines produced all across Pennsylvania. As I mentioned, Gruner is an important variety for the Pennsylvania wine industry and is grown throughout the state. With this in mind, we partnered with a variety of commercial growers across Pennsylvania in order to try and understand how Gruner Veltliner grapes and wines produced in different regions of the state either exhibit similar or dissimilar sensory qualities and aroma profiles. This project began in 2018 and is currently in its second year of data collection. We collect data on our grapevines at each site throughout the growing season, harvest the grapes, and then proceed to make wine. And on these wines, we perform various sensory trials in order to assess how they differ in aroma and taste. Most recently, I've become involved in a project that looks at the spotted lanternfly, a recently introduced plant hopper, and how its feeding during the later part of the season affects grapevine health as well as fruit quality. This project is currently underway, and these videos show insect netting cages in various stages of construction. We are building individual nets around vines at our experimental site, in which then we will introduce spotted lanternfly in order to assess how its feeding affects various grapevine qualities. I hope that this gives a quick but thorough look into the research that I'm engaged with here at Penn State, and I'd like to give a big thanks to everyone that has been involved in my program thus far. And many thanks to the wonderful members of the American Wine Society chapter in Columbus, Ohio. Without you and your generosity, this scholarship and opportunity would not be available, and for that, you have my many thanks. Cheers!
Hello, I'm Sarah Mayfield, a PhD candidate in the Department of Food Science at the University of Arkansas Fayetteville and the University of Arkansas System Division of Agriculture. I'm working under Dr. Renee Threlfall in the Fruit and Wine Lab. Arkansas has a particularly difficult climate for producing wine grapes due to high heat, high humidity, substantial amounts of rainfall, and some late freezes. Therefore, my research focuses on improving the quality of wines made from grapes that grow well in the state of Arkansas. For a portion of my project, I'm working with the University of Arkansas System Division of Agriculture wine grape breeding program at the Fruit Research Station in Clarksville, Arkansas. I'm evaluating the winemaking potential of two recently released wine grape cultivars, Enchantment, a red grape, and Opportunity, a white grape, and also two advanced white wine grape selections. We are looking at how various winemaking techniques and storage times impact the quality and marketability of the wines produced from these grapes. I also work with muscadine grapes, a grape species that is native to the southeastern United States. Muscadine wine is considered a regional specialty in the state of Arkansas, so I am evaluating how various winemaking techniques impact the color and aroma of the wine. Finally, in a project sponsored by Lalamond, we are evaluating one of their products, La Vigne. Now this is an inactivated dried yeast that is recovered from winemaking and sprayed onto the grapevines in the vineyard at the point of veraison, which is when the berries first begin to ripen. And this product has been reported to enhance the ripening of grapes and improve the flavor of the resulting wine. We are working with Chambourcin, a French-American hybrid red wine grape that is widely grown in much of the eastern United States. We are sampling berries weekly from veraison until harvest and evaluating these berries for basic composition, physical properties, and anthocyanin content. Then we are producing wine from these grapes to determine how La Vigne impacts the color, volatile aroma profile, and sensory attributes of these wines. I would like to thank the American Wine Society for supporting my education while I continue this research, which will hopefully yield positive results for the Arkansas grape and wine industry.
Hello, my name is Connor McCaney, and I work under Dr. Ryan Elias in the Department of Food Science and Technology here at Penn State University. Currently, my research focuses on pre-fermentative treatments and taking techniques used on white vinifera grapes and modifying and applying them to white flesh intercept hybrid grape varieties, specifically Traminette and Cayuga. My current research focuses on investigating the effects of applying rapid and slow-rate cryogenic maceration treatments, extended skin contact, and short-duration cold soak regimens, and their effects on final wine quality, post-bottling oxidative stability on hybrid white wines. I'm currently assessing wine quality and stability using various analytical methods and measuring total phenolics, specific phenolics such as catechin, epicatechin, gallic acid, etc. Looking at chemical age and color stability, aroma profiling, glutathione concentration, antioxidant capacity, and speciation of iron 2+ and iron 3+. In this coming year, we'll lead to another round of winemaking with the addition of short duration cold soak treatments, as well as additional analysis of thiols and terpenes. Additionally, I've conducted all of my fermentations as microscale fermentations and will continue to do so in the coming year using an exciting new product from Dr. DJ Sai, the owner and creator of the Go Fermenter. I'll be using his Go Fermenter Junior system, which will allow me to better control oxygen exposure using sealable and biodegradable fermentation bags to conduct all my treatments and fermentations. At this time, I would like to say it's been a privilege to be the recipient of the Dayton and Springfield, Ohio chapter's American Wine Society Education Foundation Scholarship in memory of David Pedrick. I'm very grateful for this honor and thank the AWSEF for their support of my research. Being able to work on and see the completion of such a meaningful project for myself and the Pennsylvania wine industry means a tremendous amount to me. And again, I would like to thank you very much for this honor, and I hope to be a major contributing factor to the wine industry for many years to come. Thank you very much for this award and this opportunity.
Hi, my name is Josh Vanderwaarde. I'm a PhD candidate at Michigan State University in the Department of Horticulture. I study viticulture under Dr. Paolo Sabatini. I'm one of the recipients of the American Wine Society Scholarship this year, and I just wanted to say a huge thank you to the Society for this award. It's really a huge honor. I also want to say thank you to those of you who are involved in the Susan Luker Scholarship. It's really a wonderful thing that not only companies and organizations, but also individuals are involved in investing in students and also the future of the wine industry in North America. So I thought I would also, in addition to saying thank you, give you an idea of what I'm working on here at Michigan State. So the problem that I'm trying to address with research is that here in cool climates, particularly in the Midwest and also the northeastern United States, we have two issues. We have very short growing seasons with cool to warm summers, and we also see a lot of precipitation being that we are right by the lakes. So the practice that I'm studying is early leaf removal, and what this does is two things. It exposes the fruit to higher radiation and temperatures during the growing season. This allows fruit to to mature earlier and reach a higher level of maturity, which is important for wine quality. And this is also important because the phenolic compounds that make up wine and are important to wine quality, such as tannins and anthocyanins and flavanols, are all dictated by radiation. So exposing the fruit to higher levels of radiation is important for wine quality. This is all I have for you, but I just wanted to say thank you so much again to those of you who are involved in awarding the scholarship. This is really a huge honor. Thank you.
Hello, my name is Rachel White, and I am a master's student in the Department of Horticulture at the University of Georgia under Dr. Kane Hickey, the Extension Specialist. For many, the feasibility of growing high-quality Vitis vinifera grapevines stops in North Carolina. However, Georgia's 60-plus wineries and over 1,500 acres of grapevines are producing many cultivars and species of high-quality grapes and the wines to prove it. The University of Georgia viticulture team has a variety of projects to help growers produce high-quality grapes and wine not only here in Georgia but throughout the Southeast. Our projects mostly deal with the common practice of delay pruning to reduce frost damage, the optimal amount and timing of leaf removal practices in the Southeast, and increasing production through the testing of different dormant pruning and trellising systems in low-cropping cultivars. Many of our growers face the need to increase production without adding more costly vines and more infrastructure in the form of trellis establishment. My project focused on an alternative, a retrofitted vertical shoot position trellis to increase yield without decreasing wine quality. The retrofitted trellising system divided the existing trellis hardware, forcing the canopy into a V shape, and doubled the fruit zone through quadrilateral cane pruning. The retrofitted trellising system with quadrilateral cane pruning was found to be a success with a 79% increase in fruit production in the second year of the project, without negative impacts on primary fruit chemistry. With such promising results, several of the vineyards in the area have been adapting the new system and retrofitting their old VSP trellis. I have been a part of the industry for 6 years now and plan to be a part of it for years to come. Thank you to the South Carolina American Wine Society Chapter Scholarship in memory of Hal Cohn. Their support of my research in the southeastern United States allows me to continue my studies on increasing vineyard and winery profitability through increased yield. I want to see the industry I love grow and thrive well into the future.